So today's deep dive is based on a really provocative document. Honestly, this text is a bit of a wake-up call. It challenges the fundamental way we visualize electricity.
And we should probably be clear right off the bat. We aren't talking about quantum weirdness or some fringe zero-point energy theory here.
No, definitely not. We are talking about basic wires, the stuff sitting in your wall right now.
Exactly. And the mission here isn't to say physics is broken or that your toaster works by magic. The goal of this deep dive is to look at how a field-first perspective, which is what this document strongly advocates for, might solve puzzles that the standard electron highway model just can't explain.
Let's start with the scenario that kicks this whole argument off. The source calls it the twisted splice.
Right. And this is something anyone who has done a bit of home repair or installed a car stereo or just messed around with electronics recognizes immediately.
Okay, let's unpack it. Say you have two copper wires. You want to join them to make a longer wire. You don't have a soldering iron. You strip the plastic insulation off the ends. You just mash the two copper bits together and you twist them up with your fingers.
You wrap it in some black electrical tape if you're feeling professional.
Exactly. It's messy, it's crude, it's the definition of good enough.
But here is the thing, and the source points this out immediately. It works. You flip the switch, the light turns on, the circuit operates.
And that right there is the paradox.
Wait, I think a lot of people might be confused by that. Wire touches wire, electricity flows. Most people would just say, yeah, metal touches metal, so the current passes. Why does the source label this a paradox?
Because if you strictly believe the standard model, the model where electricity is physically electrons flowing through a crystal lattice like cars in a tunnel, that splice should be an absolute disaster zone.
I see what you mean. The geometry of it.
Right. The source describes the wire surfaces at a microscopic level as rough and jagged. When you twist those wires together, you aren't creating a seamless pipe. You are smashing together two fractured asymmetrical surfaces.
So the lattice, that orderly crystal structure of the metal that the textbook loves to show us, doesn't match up.
Not at all. The field lattices don't match. It is far from any continuous crystalline path. If the highway model were true, imagine trying to drive a car down a highway where the road suddenly turns into a jagged, twisted pile of rubble and then connects to another highway at a weird 45-degree angle.
It would be a massive traffic jam. Cars piling up, honking, trying to find a lane.
Worse. The source says this chaotic geometry should, by all accounts, strangle conduction. If electricity truly depended on a neat, uninterrupted path for electrons to march through, a twisted splice should offer massive resistance. It should heat up immensely right at that point. It should fail to carry the full load.
But it doesn't. I mean, sure, a really terrible splice might get warm, but generally it conducts perfectly well.
Exactly. And this brings us to the second, perhaps even more damning point the source makes, and this is about speed.
Yes, the timing issue. This really feels like the smoking gun for this whole argument.
It really is. The text notes that the circuit responds at once. The moment you complete that messy connection, the power is there.
And this creates a massive hole in the drifting electron story. I think people forget, or maybe they never learned, how slowly electrons actually move. We call it drift velocity, right?
Correct. We have this culturally ingrained idea that electrons zip around at the speed of light. They don't. The signal moves at the speed of light. The electrons themselves, they're incredibly sluggish.
I actually looked this up before we started just to double check because I couldn't believe it. In a standard DC circuit, like a flashlight, the electrons are moving, what, a few centimeters a minute?
Even slower in some cases. It's millimeters per second. It's literally slower than a snail.
So let's play that out. If I flip a switch and I am strictly waiting for an electron to physically travel from the switch through the wire across that messy jagged splice and into the bulb.
You'd be waiting a while. You'd flip the switch, go make a coffee, come back, maybe read a chapter of a book, and then the light turns on. But that's obviously not what happens. The light comes on instantly.
Right. The source points out that the circuit works long before any electron could physically drift.
This is the part that always confused me in school. They tell you electrons carry the charge, but then they say electricity moves at the speed of light. You really can't have both. Not if the electron is the physical thing doing the work of crossing the gap.
Exactly. If the electron is the car, and the car is driving at 1 mile per hour, how does the package get to the destination instantly? It just doesn't add up.
So we have a messy, jagged junction that should physically block the flow of particles, and we have a reaction speed that is faster than the particles are capable of moving anyway.
So the splice is double trouble for the standard model. It's a roadblock they shouldn't be able to cross, and they're supposedly crossing it faster than they can run.
Precisely. The text says that even a poor connection, which offers a maze of micropaths, remains fully functional. This one humble fact, just the twisted splice, undermines the entire marching electron story.
Undermines the story. That is a bold statement. So the source is basically saying, look, if the electrons can't get through the rubble and they can't get there fast enough anyway, something else must be doing the work.
And that something else brings us to the core of this deep dive, the shift from particle first to field first.
Okay, field first. Let's really get into this, because I feel like field is one of those words people use to sound smart but don't actually explain. It feels a bit abstract, like synergy or quantum. How does the source define this in a way that makes sense of the splice?
Well, instead of thinking of a conductor, the wire as a highway for particles, the source asks us to think of it as a geometric permission.
Geometric permission. I actually circled that phrase 3 times in my notes. It sounds like something from a sci-fi novel. Captain, we have geometric permission to dock. What does it actually mean in practice?
It means the wire isn't the carrier of the stuff. The wire is the structure that allows the field to exist. It's the scaffolding.
Okay, hold on. Let's ground this. Going back to our messy, hand-twisted splice. How does geometric permission explain why the light turns on when particle flow fails?
Think about proximity. When you twist those copper ends together, even if it's messy, even if it's jagged, the atomic scaffolds of the two wires are brought close enough to touch in various spots.
Okay, so they're touching. But we just established that touching isn't enough to make a smooth road.
For a physical road, no. But for a field, yes. Once they touch, they propagate a single continuous domain of field. The source explains that the potential difference the voltage relaxes through this zone of permission.
Zone of permission. It sounds like a security clearance.
In a way, it really is. The wire gives the field permission to be there. The source says, once the copper ends touch, even crudely, they create a shared region of field.
So the field doesn't need a smooth road.
No. The field is a condition of space. It doesn't care if the road is bumpy, it just needs the territory to be contiguous. If the copper creates the boundary, the field fills it instantly.
I'm trying to visualize this. If the electron model is water in a pipe, what is the field model?
The source actually uses a really helpful analogy here that I think clears this up perfectly. It compares the wire to a running track.
Yes, this is a great visual for separating the track from the runners.
So imagine the copper wire is like laying down the asphalt for a running track. You lay the track from point A, the start, to point B, the finish.
The track connects the 2 points structurally. It paves the way.
Right. Now, typically under the standard model, we think the runners, the electrons, are the connection. Like the connection only happens when a runner physically gets from A to B.
That's the commuter model again. The message is carried by the messenger.
But the source argues you don't need runners on the track for the track to effectively connect the 2 points. The functionality, the actual connection, exists just because the track is there.
That's a key distinction. The track is the connection.
Exactly. The track itself is the permission for the race to happen. Whether the runners are moving or not, the connection between start and finish is established by the geometry of the track.
So applying this to our splice, I twist the wires. I am essentially paving that last piece of the track. Even if the pavement is a bit ugly there, even if it's got some potholes, the track is now continuous. The field, the potential for the race is established instantly across the whole length.
And because that field is established, the pressure difference collapses. The energy moves. The runners, the electrons, are secondary. They might shuffle around as a result. They might start running because the track is open, but they aren't the cause of the connection.
That really changes how you look at a wire. It's not a pipe, it's a scaffold.
A scaffold is the perfect word. And the source actually says the atomic scaffold provides the geometry, but the combined homogenized field completes the connection.
It almost makes the wire sound passive, like it's just sitting there letting the field do all the heavy lifting.
In a way, it is. The wire defines the shape of the field, but the field is what carries the energy.
Now I want to play devil's advocate for a second. I know what some listeners might be thinking. This sounds cool, it sounds elegant, but is this just fringe theory? Is this just one person ranting about copper wires in a basement somewhere?
That is a very fair question. We should always be skeptical of new theories that claim to overturn the basics, but the source anticipates this entirely. It brings in a heavyweight witness to back up this logic: chemistry. Specifically, the benzene ring. So a benzene ring is a hexagon of 6 carbon atoms. It's incredibly stable, which actually baffled chemists for a long time. In chemistry, they talk about the electron cloud or delocalization of the benzene ring.
Right. I remember drawing the hexagon with a circle right in the middle. The circle represented the bond.
But here's the key. Chemists already accept that this isn't electrons running laps around the ring like tiny planet. That old Bohr model of the atom, chemists threw that out regarding building molecules a long time ago.
They don't think of them as particles in orbit anymore?
No, they accept that the field spreads across all 6 carbon atoms and acts as a single entity. The ring is stabilized because of this shared field. The source explicitly says the structure may be supported and enhanced by matter, but the coherence belongs to the field.
So the chemists have essentially been doing field first all along.
They have. They understand that the stability comes from the field being shared across the geometry. The source argues that the copper wire is really just a linear version of this exact benzene principle.
It's just a really long, straight benzene ring.
In principle, yes. The matter, the copper, supports the structure, but the coherence, the thing that makes it conductive, belongs to the field.
That is a huge validation. Because if you accept it for benzene, you kind of have to accept the logic for the wire. It makes the electron flow model feel, well, kind of childish, like a simplified story we tell kids, because the reality is too abstract.
And that is exactly how the source frames it. The electron flow is a convenient fiction. It's a heuristic, it helps you calculate current, it helps you design a basic circuit board, but it doesn't explain conduction at a fundamental level. The field is the real agent.
So if the field is the real agent, and this explains the splice so perfectly well, why are we still teaching it the other way? Why is the commuter train model the gospel? Are we just lying to high schoolers?
Well, lying might be a strong word, but we are certainly simplifying. And this brings us to the more philosophical part of the text. The source has a bit of an edge to it when it talks about the scientific community.
It definitely does. It mentions pre-approved dogma, that is, fighting words in academia.
It argues that the field-first perspective is dismissed immediately, not because it's scientifically wrong, clearly the benzene example shows it's accepted science in other contexts, but because it challenges the way things have always been taught in physics.
There's that one line that I absolutely loved. It says, the standard model's inability to explain the splice is the Sudoku problem expressed in copper.
Think about a Sudoku puzzle. You know the rules, you have all the numbers filled in, everything looks great, but then you get to the last box, the splice, and the number just doesn't fit. You have a 5 where a 5 absolutely cannot be.
If the rules of Sudoku are correct, the 5 shouldn't be there. But in our case, the splice works. The light turns on. The 5 is there.
Exactly. And instead of erasing the other numbers and fixing the puzzle to accommodate the 5, the standard model just ignores that box.
We ignore the box because the rest of the puzzle looks nice. We say, well, the splice works. Let's just not worry about the microphysics of it.
But the source says this isn't good science. You can't just ignore the anomaly. The anomaly is usually where the real discovery is hiding.
It also reframes how we think about things breaking. If a wire snaps or a connection fails, under the standard model we think, oh, the road is blocked. The cars just can't get through.
Right. That's the traffic jam view.
But under the field-first view, when the material becomes disordered or fractured, it's not that the passage of electrons is blocked. It's that the geometric permission has failed.
The permission is revoked.
Exactly. The ability to sustain that shared field is completely gone. When that geometry breaks, the field continuity breaks with it.
It feels much more immediate. It explains why a loose wire flickers so instantly. It's not about particles bumping into a physical wall. It's about the field struggling to maintain its coherence across a gap. It's flickering between permission granted and permission denied.
And this leads right into the source's plea for what it calls multipolar perspectives.
Yes, this is crucial. Multipolar perspectives. Is that just a fancy way of saying keep an open mind?
A little more specific than that. It means good science shouldn't fear alternatives. The scientific method is supposed to be about constantly questioning assumptions. The source says we should hold perspectives open until the evidence is unequivocal.
And the argument here is that the evidence for the marching electrons is not unequivocal, precisely because of the twisted splice.
Correct. The twisted splice is cited as enough evidence to at least keep the conversation open. It resolves contradictions that the standard model just actively avoids.
It's interesting because it frames this not as anti-science, but as pro-inquiry. I think often when people challenge standard models, they get labeled as deniers or contrarians.
The text explicitly says this interpretation is not anti-science. It uses the exact same empirical observations, the wire, the electricity, the light, but it shifts the emphasis to what the system must be doing if conduction thrives where electron flow should fail. It's refining the model, not destroying physics.
It's like looking at the same painting, but focusing on the negative space instead of the subject, and suddenly the shape just makes a lot more sense. So, where does this leave us? We've gone from the tidy procession of charges, those little blue balls in the textbook, to the chaotic reality of a twisted wire.
And we've arrived at the elegance of the field-first scaffold.
When I flip that switch, I'm not opening a gate for a bunch of tiny particles to rush out like water from a hose.
You are activating a geometric permission. You're establishing a condition where a field can exist, allowing the pressure difference to collapse instantly across the whole circuit.
It's not just plumbing, it's geometry, it's structure, it's faster than thought.
It aligns much better with the reality of how fast and responsive electricity actually is. It treats the wire as a stage, not the actor,
The wire is the stage, the field is the play.
and the electrons.
This deep dive has really been a lesson in questioning the simple stories we are told. It's not just about wires, is it?
Absolutely not. It's a really powerful reminder that textbook doesn't always mean truth. Sometimes it just means convenient approximation. And sometimes that approximation hides the real beauty of what's actually happening. We teach the electron model because it's easy to grade, not necessarily because it's the deepest truth.
Thanks for joining us on this deep dive. Keep questioning the geometry.
And mind the field.